this video, I'm going to discuss how to calculate measures of variation using quartiles and percentiles. Okay, so we're going to start with the interquartile range. To explain the interquartile range, I'm going to draw a frequency histogram. Okay, I'm not drawing this to look like any particular type of histogram. Okay, so it could look like anything. All right, so let's see. What is the third quartile? That's the mark for which 75% of the data is behind, right? So this would be like the third quartile, right? And what is the first quartile? So the first quartile would be somewhere where 25% of the data is behind it, right? So 25% is less than the first quartile, and 75% is less than the third quartile. All right, so if we take the difference between the two quartiles, that means that 50% of the data is between the first and the third. So 50% of the data is between the first and the third, right? Because 75% is less than the third, and 25% is less than the first, so that leaves 50% between. Right. So that's what the interquartile range is. It's the difference between the third quartile and the second, which is basically the range for which 50% of the data lies. Right. So this is basically, it's the range of which 50% of the data lies. All right. So you know, this is really useful. Remember, we also had discussed calculating range. Remember what range is? Like just regular range. It would be the max minus the min, right? So range is the max minus min. And we said, you know, this isn't a great measure of variation because it's very, you know, affected by outliers. Well, the nice thing about the interquartile range is it tells you something informative about the variation of the data. It tells you the range for which 50% of the data lies, but it's not as affected by outliers, right? Because the third and first quartile aren't as affected by outliers as, say, you know, the min and the max are. Okay. The semi-interquartile range, this is also called the mid-quartile. It's basically the interquartile range divided by 2. So this is basically half the range for which 50% of the data lie. All right. So yeah, this is just another way of saying basically a very similar thing to the interquartile range. It's just another way of representing it. You could take the interquartile range and divide it by 2, and that'll give you the semi-interquartile range. All right. Lastly, there is the last thing that we're going to go through at least is the 1090 percentile range. All right. So if we were to draw this out, some sort of histogram. Okay, the 1090, what it is it takes wherever the 90th percentile, the P90, the 90th percentile, and the 10th percentile. Okay, and so how much is between here? Well, that would be 80% of your data, right? Because there's 90% is less than the 90th percentile, and 10% is less than the 10th percentile. So 80% of your data is between the 10th and 90th percentile. Okay, so the 1090, this is the 90th percentile minus the 10th percentile, and 80% of the data lies, or it's the range for which 80% of the data lies. So let me write that. The range for which 80% of the data lies. Okay. All right, so now let's go ahead and let's do an example. Below is a random sample of salaries of 6 individuals during their first year after completing a bachelor's degree. So let's go ahead and calculate all 3 of those measures of variation: the IQR, the semi-IQR, semi-interquartile range, and then the 1090 percentile range. All right, so let's go ahead and start with IQR. So IQR, this is the third quartile minus the second quartile. So to calculate that, I'm going to need to calculate the first, or the third and the first quartile. So I need to remember how to do that. First thing I'm going to do is I'm going to sort my data. So 28,000, 29,000, 32,000, 36,000, 42,000, and 60,000. Okay, make sure I have all the data points. This is 1, 2, 3, 4, 5, 6. All right, so this is 6 individuals. So yeah, I got them all. All right, so that's the sorted data. So to calculate I'm going to go ahead and start with the first quartile. So just calculate the first quartile. That's the 25th percentile. So I'm going to use this equation, K over 100 times N, right? So this would be 25 divided by 100, which is 0.25 times 6, right? So that would be 1.5. Okay, so 1.5. Now remember, if this comes out to a decimal, you go up to the next whole number, which is 2. All right, so I'll go to 2. So the first quartile then is the second observation, which is 29,000. Okay, the third quartile would be 75 divided by 100, which is 0.75 times 6, which is 4.5. Okay, that's also a decimal, so round it up to get 5. 5, that's 42,000, right? The fifth observation is 42,000. All right, so then the interquartile range. Okay, that'll be 42,000 minus 29,000. We can pull out our calculator if we want. Let's go ahead and clear it out. So 42, 1, 2, 3, minus 29, 1, 2, 3. So we get 13,000. All right. So this means that 50% of the data lies within a range of $13,000. So 50% of the 50% of the salaries lie within a range of $13,000. Okay, so that's the interpretation for the interquartile range. All right, so now let's go ahead and do the semi-interquartile range, or the semi-IQR. Okay, so just take the IQR and then divide it by 2. So that'd be 13,000 divided by 2. Right? So that would be 6,500. Okay, so 6,500. All right, lastly, let's calculate the 1090 percentile range. So let's calculate the 1090 percentile range. Okay, so to calculate this, well, first we'll need P90 and P10, right? That's what the percentile range is, the 90th minus the 10th percentile. So I'm going to calculate L. I'm going to calculate first the 10th percentile. So 10 divided by 100 times 6. So that'd be 0.1 times 6, which is going to be 0.6. All right, so round that up to the next whole number. That'll give us 1. Okay, so the first observation is 28,000. So P 10, the 10th percentile is 28,000. Okay, now let's calculate it for the 90th percentile. Okay, so that'd be 0.9 times 6. Go ahead and pull out our calculator. So 0.9 times 6 is 5.4. Right, round that up to the next whole number. That'll be the 6th observation. Right, so the 6th observation is 60,000. So P90 is 60,000. Right. So actually, it turns out that the 1090 percentile range for this data set is going to be the exact same thing as the range, because this is the min and this is the max. So I'm going to calculate basically the max minus the min. And that's just because this is a small data set. In larger data sets, the range and the 1090 percentile range won't necessarily be the same. All right. So let's go ahead and calculate it. So 60,000 minus 28,000. Pull out our calculator for that. So 60 minus 28 is 32. $32,000.